Example 3.5. A network of resistors is connected to a 16-volt battery with internal resistance of 1 ohm, as shown in figure. A. Compute the equivalent resistance of the network. B. Obtain the current in each resistor. C. Obtain the voltage drop across AB, across BC, and across CD. And now the network is given to you. See, here, first we can say this thing. These four ohm resistors between A and B are connected in parallel. Similarly, 12 ohm and 6 ohm between C and D are also connected in parallel. So, the equivalent resistance between A and B, that will be 4 both are same one parallel. So resistance across AB will be 4 by 2, that is 2 ohm. Now resistance across BC, that is simply 1 ohm as it is. Then across C and D, 12 ohm and 6 ohm are parallel. So resistance across a CD, that is equal to 12 into 6 upon 12 plus 6, it will come to 4 ohm. Then we can say all these three are in series. So resistance across AD, that is resistance AB plus resistance BC plus resistance CD. So 2 plus 1 plus 4, that is 7 ohm. So this is the resultant resistance between A and D. Clear to all of you up to this one? Now, current supplied by the battery of 16 volt to the network, that is I equal to E upon R plus R. As per that equation, E, that is 16 volt given to you, capital R, that is the equivalent resistance of the network between A and D, and that we calculated 7. And small r, the internal resistance of the battery, that is given to you 1 ohm. So 7 plus 1, 8, 16 by 8, that is 2 ampere. Now current constituted here, that is 2 ampere. Now when this 2 ampere current is divided in two parts between A and B, but see here, both the resistors are identical one, 4 ohm, 4 ohm. So 2 ampere current that will be distributed equally. So 1 ampere that will flow through the upper 4 ohm resistor, and 1 ampere current will flow through the lower 4 ohm resistor. Now when from both the resistor the current flowing, that is 1 ampere, then the potential difference across both one, that is 4 into 1, as per that between A and B, the potential difference that will be of 4 volt. Clear to all of you up to this one? Then after, when current reaches at B and comes out from B, again it will be 2 ampere through this 1 ohm resistor, and therefore 2 into 1. So 2 volt potential difference will be there between B and C. Then after, at C, again these 2 ampere that will be distributed in two part. But now see here, between AB, the potential difference is 4 volt. Between BC, it is 2 volt. And when 2 ampere current is flowing through this cell, so here internal resistance of the cell is given to you 1 ohm. So potential drop will be 2 volt. So 4 plus 2 volt, 6 volt plus 2 volt, 8 volt. And total voltage of the battery, that is 16 volt. It implies that 16 minus 8, that much potential drop will be across CD. It implies that across 12 ohm resistor and 6 ohm resistor in parallel combination, the potential difference across each one, that is same one. So here across CD, the potential drop, that will be 8 volt. So current through 12 ohm, I, that is V by R. So I1 current through 12 ohm, that is 8 by 12, that is 2/3 ampere. Similarly, we can calculate current through 6 ohm resistor, that is I2 equal to V by R as per that 8 by 6, that is 4 by 3 ampere. Clear to all of you? So now here current through each resistor, potential difference across each resistor, the equivalent resistance of the network, everything is calculated. See, here across CD, the potential drop, that is of 8 volt, that we calculated here. And therefore, we calculated the current through 12 ohm and 6 ohm. But suppose this potential drop across this combination is not known, but the total current here, that is 2 ampere, means total current is known. Then how this total current will be distributed in both the resistors? So for that, we have the equation I1, that is the current through resistor R1, that is R2 upon R1 plus R2 into total current I, and I2 equal to R1 upon R1 plus R2 into I. The resistor which you say, that is R1, through it you have to take current I1, and the resistor which you say, that is R2, through that you have to take current I2. So your total current I, that will be distributed in both the resistors as per this equation. Note down this equation.